So today what we'll be working on is fractional exponents. Now, basically what you need to recognize is that powers can be expressed as a base with a fractional exponent. So now let's consider these two cases. If we look at an equivalent value for 1/2, right? And 1/2, that would be 0.5. So if we look at these two fractional exponents, we end up with a base of 25 and a base of 25. So normally we would just add these two exponents. So we would end up with, well, 25, and 1/2 to 1/2 is just 2/2, which ends up being 25 to the exponent 1, which equals 25. We can do the same for our 8 to the 1/3 multiplied 3 times. 8 to the 1/3 is really an exponent. So now we have 8 repeated 3 times. So we have to add the exponents 3 times. So we have 8 to the 1/3 plus 1/3 plus 1/3, which is just 8 to the 3/3, which is just 8 to the 1, which is just 8. So based on this concept, if you think about it, this denominator on the exponent, it kind of works as like the nth root of x. That's what all of this means. So if I have x to the 1/n, I rewrite this as the nth root of x. Now, I'm actually going to get you to change the way you write this. You're going to write this as, with a bracket, to the exponent 1. You'll notice that the nth root, the denominator that we have here, is the same as the nth root of x. And the exponent 1 that we dealt with goes on the outside. Now, the same can be said for the negative root of something. So in this case, we have the following. X to the negative 1/n is the same as 1 over, well, we flip our fraction and we get the nth root of x raised to the 1 in the end. We'll work through that during our struggles today. Let's move on. Now, to evaluate these problems on your calculator, we're going to need one of the following buttons. Now I'm going to write these in blue. Basically, the first button that you need looks like this. The xth root of something. Or you're going to need something that looks like this. X to the 1/n on your calculator. To access the first function, you're going to have to use shift x to the n, and that will give you this form on your calculator. On some other calculators, for this one here, we're going to have to use shift x to the box. Or you could do it the long way by using the normal exponent button. We basically enter the fraction as our exponent, but we got to use brackets to do that. And I'll show you how that works. So you would write 8 to the 1/3. If that was what we had to do on our calculator, we would write 8, and then we would use our shift button, raised to, ready? Notice I have a bracket here. Bracket 1 divided by 3. And we get the appropriate calculation, and we end up with 2. When I ask you to determine the following by showing all steps, it means we're actually going to have to go back and show the rooted expression of each of the terms. So now our first problem is 25 to the 1/2. So we're going to write, well, we're going to put a root sign of 25, right? Now, remember, the denominator of the fractional exponent goes on the root. So we're going to put second root raised to the 1. Now, BEDMAS tells us right away we must calculate the inside first. So we calculate the inside first, and then we calculate the outside. So now let's take a look at that. The square root of 25. We use our calculator, we put da 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 da, and we get 5. And then we're raised to the power of 1. And anything raised to the power of 1 is just its number again. So we end up with 5. Now let's do the same for the next problem. So now when we look at this problem, we write the square root of 81. And because we have a denominator of 4, we're going to put that on the root sign. And we're going to raise that to the 1. Now, remember, just like BEDMAS says, we have to do the inside part first. We calculate the inside part first. So now, the fourth root of 81 gives us, when you punch it into your calculator, you get 3. 3 raised to the 1. End of story. Bob's your uncle. 3 to the 1 is just 3. When you punch that in your calculator, you're done. Now, let's take a look at this next problem here. Negative 64 to the 1/3. We apply all the same rules as before, and we get the following. So remember, the denominator goes on the root sign, and the numerator goes on the outside of our expression. Calculate the inside using the third root of negative 64. Which ends up being negative 4 to the 1 equals negative 4. I had to put my negative 4 in brackets and raise it to the power of 1. You'll have to make sure that when you punch that in your calculator, negative 4 is in a bracket. Use that bracket raised to the power of 1 to get the appropriate answer. So now we have 16, and this is to the negative 1/2. So remember what I told you. We have to flip our fraction first. So let's do that. So we get 1 over 16 to the 1/2. Now the next stage is to remove the 1/2 and change it into a radical. So we'll write 1 over the second root of 16 raised to the 1. The second root of 16 is 4 when you calculate that, raised to the power 1, which ends up being 1 over 4. Problem is 27 to the negative 1/3. So 27 to the negative 1/3. Follow the same steps that we did before, and you'll get the following. So you'll notice I get 1 over 27 to the 1/3 in order to remove the negative exponent. The next thing we have to do is we have to change our fractional exponent into its radical form. So we put the third root of 27 all raised to the 1 on the denominator. And we do the same, and we go through the rest of the calculations. You'll notice every time I do these simplifications of the bracket, I leave the number inside a bracket. And that is because sometimes, like one of our previous questions, question number 3, you end up with a negative as the base. And when you do that calculation, you'll need that negative inside the bracket to get the appropriate answer. Sometimes I'm a jerk, and I'll give you problems that look like this. You know that 0.25 as our exponent on this problem, negative 16 to the negative 0.25, is really, well, 0.25 is just 1/4. So we're actually going to punch that in our calculator. We got negative 16 all raised to the negative 1 over 4. Now, in order to do this problem, you're going to have to flip you're going to have to write 1 over negative 16 all raised to the 1/4 in order to get rid of the minus sign on the exponent. So now that you've done that, you're going to have to apply the radical form. So that means we have the 4th root of negative 16 on the bottom, raised to the 1, and we put our fraction over top. Now, you're going to find out that there is going to be an error here. And now the reason why we have this error is because of this exponent. The rooted exponent must be odd if we take a negative base. A negative base. So that means this problem, when you punch that in your calculator, is not a number. NaN for not a number. Now your homework for today is page 39, 1, 2, and 5.